Alright guys, today is the 10th and we are going to be going over two-step equations. I'm on page 4, so you do it how you want to. Whatever page you're on, awesome. Okay, so let's open up to next page we're on. Page 4, two-step equations. So the cool thing about two-step equations is step 1 is going to be the exact same as what it was for the one-step equations. Alright, so it's still going to be isolate the variable by using the inverse operation. So we get the variable by itself by using the opposite operation. And in step 2, you have two options here. Okay, so you either divide both sides by the coefficient, or you multiply both sides by the denominator. And we're going to work on some examples. So let's do 6x plus 8 equals 50. So first thing we need to do, first step, is to isolate the variable by using inverse operation. Well, if you were doing math when you were younger, you know the first thing you learned when you were learning math was addition and subtraction. So it's a lot easier for us to work with the addition and subtraction first before we start working with something that's being multiplied or divided. Alright, so I actually want to keep the 6x and I want to get rid of the plus 8 first before I do that. So the opposite operation, the inverse operation of plus 8 is to subtract 8. And what I do to one side I have to do to the other. 8's will end up canceling. I have to take the 6x as a whole and bring it down, because remember that 6 is attached to the variable by multiplication in this case. So it's attached like glue and I can't separate it just yet. And then 50 minus 8 is 42. So now I have 6 times x equals 42. So I have my two choices. I either divide both sides by the coefficient or I multiply both sides by the denominator. Well, the 6 right here is the coefficient for x. Okay, it's the number in front of the variable that is attached to the variable by multiplication. So I'm going to actually divide by the coefficient, in this case 6. And then what I do to one side, I do to the other. That way my 6's will end up canceling, and I'll be left with the x by itself. And then 42 divided by 6 is 7. And if we work backwards, 6 times 7 is 42, plus 8 equals 50. That ends up working out, right? We get a correct answer there. So let's do this one over here. We have 11. Let's do another one. We have 11 equals 2x minus 5. Now, I know what some of y'all like to do. You don't like to have the x on the right side of the equation. That's fine. We can switch them. All we're going to do is we're going to take the 2x minus 5 as a whole and move it to the left, and the 11 and move it to the right. So when we rewrite it, it would be 2x minus 5 equals 11. I don't change any of the signs. I don't change anything up. Alright, it still stays as 2x minus 5. All I did was I shifted it to the left side of the equal sign. Now, from here, same idea. What did you learn first? Addition and subtraction. So we're going to work with the addition and subtraction first. So to get rid of the negative 5, I'm going to do the opposite, and I'm going to add it. Forgot to draw on the wall. I'm going to add 5. What I do to one side, I do to the other. The negative 5 plus 5 is 0, so they'll go away. I have to bring the 2 times x down as a whole, and then 11 plus 5 is 16. Now right here, we can ask ourselves, hey, what can I multiply by 2 to give me 16? Right? And we should be able to get an answer. Right? So we know what the answer should be. Right? It should be x equals something. In this case, 2 times what gives me 16? Well, 2 times 8 gives me 16. So you can think of it that way as well. Now the actual math behind it, what you would do is we're going to do the opposite of multiplication, and we would divide by the coefficient. And then guess what 16 divided by 2 is? 8. Now, working on another one, I have 7 minus 3x equals 34. So, when I want to get rid of this 7 here, right? So we're working with addition and subtraction first because that's what you learned first, right? It's a lot easier to do that before we start multiplying and dividing stuff. So in order to get the negative 3, this by itself, the variable by itself, I have to get rid of this 7 first. Well, remember, this is still a positive 7, and the inverse of positive 7 would be minus 7. And what I do to one side, I have to do to the other. The 7s will cancel. Now, I didn't subtract 7 from the variable because constants can only go with constants and variables can only go with variables. So what I'm going to do is I have to bring the negative 3x down as a whole. That negative sign in front, the subtraction sign in front, is attached to the 3 and it makes the 3 negative. So this is actually negative 3 times x is equal to 34 minus 7 is going to end up being...
Teachers, at this time, please stop what you are doing and submit your official daily attendance.
27. Ends up being 27. Now, from here, what I'm going to do is I need to either divide both sides by the coefficient or multiply both sides by a denominator. Well, in this case, I don't have a denominator, I have a coefficient, so what I'm going to do is I'm going to divide by the coefficient. The coefficient isn't just 3. It's actually negative 3. So I have to divide by negative 3. The reason being is I want to get rid of this negative sign. I don't want to have a negative variable. And remember, if we do our triangle correctly, if I have two negatives, a negative times a negative will give me a positive. So I need to divide, or a negative divided by a negative will give me a positive. So if I have a negative number here, to make it positive, I have to divide it by a negative number as well. So negative 3 divided by negative 3 will cancel out, and I'll be left with positive 1x. And then what I do to one side, I have to do to the other. So 27 divided by negative 3 will end up giving me negative 9. So let's do another one. X divided by 2 minus 7 equals 9. So here again, this is division. I don't want to work with that first. Let's work with the addition and subtraction first. So to get rid of minus 7, I have to do the opposite of minus 7, and I have to add 7. What I do to one side, I do to the other. The 7s will cancel. And I have to bring the x divided by 2 down as a whole. The x and the 2 are attached to each other. I can't just bring the x down, I can't just bring the 2 down. I have to bring the entire fraction down. 9 plus 7 is 16. Now, again, here's a good way to think about it, right? We can think, what number divided by 2 will be 16? Or we can do what I said. We either divide both sides by the coefficient, or we multiply both sides by the denominator. Well, in this case, I have a denominator. My denominator is 2. So I'm going to multiply both sides by 2. I have a 2 on top, a 2 on bottom. They cancel. And I'll be left with x by itself. And 16 times 2 is 32. So we'll do a couple more and then we'll be done. So next one, 11 equals x divided by negative 5 plus 8. So draw my wall. I don't want to mess with the x divided by negative 5 yet. I want to leave that alone because I want to do the addition and subtraction first. It makes my life a little bit easier. So let's get rid of the positive 8. Well, to get rid of the positive 8, I have to do the inverse of positive 8, and I have to subtract 8. And what I do to one side, I have to do to the other. My 8's cancel. 11 minus 8 is 3. And I'm going to bring the x divided by negative 5 down. And I have to bring the entire fraction down. I can't just bring a little bit of it down. Now again, two options. I either divide by the coefficient or I multiply by the denominator. So again, I have a fraction here. I have division. I'm going to do the opposite. I'm going to multiply by my denominator. Now, I'm multiplying by the negative 5. Not just 5. I need to multiply by negative 5. That way I completely get rid of the denominator. And I'll be left with x on the right side of the equation. And on the left side, I have negative 5 times 3, which will be negative 15. One more. Negative x plus 7 equals 14. So again, I need to get rid of the addition or subtraction first. Don't mess with the variable just yet. I got to get rid of the constant first. So we have plus 7. I'm going to do the opposite of adding 7. I will subtract it. What I do to one side, I do to the other. These end up canceling each other out because 7 minus 7 is 0. Again, I have to bring down not just the x, but I have to bring the negative sign down in front as well. 14 minus 7 is 7. I cannot have a negative variable. So to get rid of the negative variable, remember, there is still an imaginary 1, an invisible 1, not imaginary, an invisible 1 in front of that x. So this is actually negative 1 times x. So to get rid of the negative sign in front, I have to divide it by negative 1 on both sides to get rid of the negative 1 in front of the x. That way I now have a positive 1x. And on the right hand side I have 7 divided by negative 1, which would be negative 7. Now there is a little shortcut I can do for those. Once I get here, negative x equals 7. If you remember the rules and you go, okay, hey, I have a negative variable here. Alright, I can't have a negative variable. I need to change it to a positive. Well, that's all I got to do. If I change this to a positive x, right? Now, if I change the sign of one side of the equation, I also need to change the sign of the other side of the equation. So I turn this from a negative to a positive, so I have to turn this from a positive to a negative, and I'll still be able to get the same answer, x equals negative 7. That'll be it for today. I'll post a worksheet later today for y'all to work on as well, going over these, and it'll be due on Monday. Y'all have a good weekend.